Hello, and welcome to part 2 of this circuit series. That was a bad joke. We're now going to start talking about potential difference in series and parallel circuits, and then talk about power supplies in a series circuit as well. So let's jump straight in. First off, potential difference in series. The rule, according to this, is that the potential difference is split across or split between each component. Now, it's very, very important to mention that this is not equally. It's only equal if every component has the exact same resistance. Generally, in a GCSE question, you won't be asked about that with equal resistances. So we need to be able to calculate how much each component, how much of a share each component gets. So here's an example. Let's say we had a circuit with an ammeter and two resistors. It can be any resistive components as long as we know its resistance, with a voltmeter across each one, V1 and V2 respectively. Let's say the power supply gave a potential difference of 10 volts and each resistor had a value of 2 ohms and 5 ohms, respectively, like so. Now we want to find out what V1 and V2 are. Well, there's several ways of doing this. Some people start talking about ratios, which I just don't think is a really good idea at all. I personally prefer to do it more logically. So first off, let's talk about what we need to find out. I would recommend that the first thing you should do is find the current through the entire circuit. Now, you all need to go back to some of our earlier rules. To find the current through the entire circuit, you need to use V over R. The resistance in this case is going to be the sum resistance of the entire circuit. That's going to be 10 over 7, which equals 1.4 amps. Now, to find V1, we're going to use V equals IR. But the R we're using this time isn't the resistance of the entire circuit, it's the resistance of the component in particular. So this would be 1.4 times whatever the first resistor is, which is 2 ohms, which equals 2.8 volts. And then for V2, same equation again, V equals IR, equals 1.4, but this time is times in by 5, which gives us an answer, running out of space here, of 7 volts. Quite simple. Now, I know it's split between each one. It doesn't exactly add up to 10. That's because I rounded up when I did this answer. It's actually 2.8 something. I rounded down with the next one, etc. So that's where those missing volts have gone. But generally, if your readings for each of these voltmeters add up to round about 10 volts, you've pretty much got it on the nose there. There's other reasons why I don't exactly match. There's something called internal resistance, which you'll learn about at A level, etc. So that's the first rule. Second rule is about potential difference in parallel. Now, we have actually already gone through this rule, the idea that each branch has the same PD, or the same potential difference, as the supply. So an example of which, I will have to rub this off to get a bit more room. Please feel free to take it down. So we have 10 volts, and whoops-a-daisy, that went a bit wrong. A voltmeter across each of these components. Very simple, no equations necessary. According to the rule, whatever this potential difference across the cell is, each branch will be the same. So if we've got 10 volts here, V1 and V2 will also equal 10 volts. Now, the only change that might occur with this kind of rule is if you've got two resistors. The important thing to remember that this will be the potential difference across both resistors, not an individual one. So in this case, well, if I just add individual voltmeters for each of these resistors, V3 and V4 respectively, in this case, V1 equals V2 equals V3 plus V4, linking in with our previous rule. So in other words, 10 volts across this power supply means 10 volts across each branch, which means 10 volts across this entire branch, of which V3, the potential difference across each component, V3 and V4, will add up to 10 volts. So that's number 2, or second one of these PD rules. The third one is concerning power supplies. Now, first off, we need to make sure we know how to define our power supplies. What do you think this is? Please pause the video and write it down. The answer is a cell. If we have more than one cell in series like so, that is called a, pause for now, a battery. So, what this rule says is that if each cell is worth 3 volts, a battery of more than 2 cells, so of more than one cell, so 2, 3, 4, etc., will be the sum of each one. So this one will be 6 volts. Following this rule, what do you think this is? Please pause. You should have hopefully got that it's 9 volts. Now, there is an exception to this rule if one of the cells has been swapped around, or if more than one has been swapped around. So let's say we had 2 like so. Whoops, a daisy. Let's try that again. And one of them has been reversed. What do you think the potential difference of this will be? Please pause and give it a go. Okay, the answer you should have got is 3 volts, and I'll tell you why. The potential difference is basically cancelling each other out in these 2 cells. If these cells face the opposite way, if you think about what a cell actually is, a positive end and a negative end, causing an attraction/repulsion of electrons which allows it to travel through the circuit, these 2 are essentially pushing or pulling against each other. So they cancel out. The only one that's doing anything is this one cell here. Hence, 3 volts. Okay then, that's enough of a go-through. Let's try a summary question. So as before, I'm going to draw it out. What I would like you to do is I would like you to copy it out into your book or paper and basically just give it a go. So we have A1, ammeter 1 here. This goes into a parallel circuit with a resistor like so, and another ammeter. We're going to be combining some of the rules that we've learned in our previous video with this, so if you've not already seen my previous video, it will be a good idea to finish watching that one before you try this question. So this is A4, and then we've got another branch, V2. V1 is going to be across this one, and a 6 ohm resistor. This one's a 4 ohm resistor, this one's a 5 ohm resistor. Here's A3, and there we are. So, you need to find V1, V2, A1, A2, A3 and A4. The only additional piece of information I'm going to give you is that one cell equals 5 volts. What I'd like to do now is I would like to pause this video, copy it down, give it a go, press play, and I'll go through the answer. Okay then, well hopefully you didn't find that too difficult. The first thing to find out is what the power supply is actually giving us. Remember, we have 2 cells here facing the opposite direction, so they cancel out. So the potential difference given by the power supply is 5 volts. That means that V1 is also 5 volts, according to one of our laws. Now, some of you might be thinking, how can this be true? We've got the ammeter there. Ammeters are designed to read current, but hopefully not interfere with it. So we can ignore resistive components of ammeters. Moving on to the next part of our problem, we need to find A2. So using I equals V over R, so for A2, I equals V over R equals 5 over 5 equals 1 amp. Okay then, so now to move on to the next part. Now, you might suddenly get a bit stuck here and think, oh gosh, I don't know what to do next. In this situation, I would recommend finding A3 next. That's really the next one you can find because you've got a power supply, so it's 5 volts across this entire branch, and you've got the resistance, so you can find A3. So that's our next port of call. A3, we're using I equals V over R equals 5 volts over the sum resistance, 4 plus 6, which makes 10 ohms, which equals 0.2 amps. Now, as you can see, I'm running out of space a bit here. So what I'm going to do is I'm going to add the values I've already found to my diagram. This is, oh, nope, sorry, I made a mistake, I do apologise. This is 1 amp. This is 0. I do apologise. That isn't 0.2, that is 0.5. Well spotted to all of you who found that. Of course, I was testing you. I do apologise. 0.5 amps. And our V1, which we found to be 5 volts. Okay, so let's rub this off. So, we now need to find A1, A4 and V2. A1 and A4 should be very, very easy. Going back to our previous examples, A1 equals A4 equals A2 plus A3. Therefore, A1 equals A4 equals 1 plus 0.5 equals 1.5 amps. Very simple. Now for the last part, to find V2. Now for V2, we'll be using V equals IR. I we already know is 0.5. The resistance we're using this time is just a 4 ohms, remember. So equals 0.5 times 4 equals 2 volts. And that's it. Hopefully you found all those. Please leave any comments, queries, etc. And best of luck in your revision. Hopefully I'll have Half-Life Part 2 up as soon as possible. Thank you very much and best of luck.